We're going to take a look at scientific notation today. Now, you guys are probably all familiar with scientific notation. You guys know we use scientific notation to write really big or really small numbers. Things like the speed of light, 3 times 10 to the 8th meters per second. That's 300 million meters per second. It's a lot of zeros. Or Avogadro's number, for those of you who have taken chemistry, you know that's the number of atoms in a mole, 6.022 times 10 to the 23rd. It's a number so big we don't really have a name for it, and nobody wants to say all those zeros, so we say times 10 to the 23rd. Okay? Anytime you have a number in scientific notation, you have two basic parts. You have this thing right here. That's called the mantissa, and I'm never going to ask you to know that, but it's the value that we're dealing with, 6.67. Okay? And then this decimal point is actually a placeholder. It tells you about the value, and so the exponent over here tells us where that should really be. Okay? And that negative is a direction indicator. Okay? If there's not a negative, then it's assumed to be positive, and that also indicates a direction. And the 11 is how far. Okay? So the exponent tells how far and in what direction to move the decimal point. So 6.67 times 10 to the negative 11th, we should move this decimal point to the left because it says negative. Okay, so negative means to the left. Of course, positive means to the right. Okay, we should move this decimal point to the left 11 places. So I'm going to start, and I know 11 places means one place here, and then I need 10 more places, which means I need 10 more zeros in front of this 6. So I'm going to go 0, point, and then 10 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then my 6 is 11, 6, 7, okay, and now I've put this number into standard form. That's how we would actually write it out, and this is why we use scientific notation. Now I do want you to note something on this number. Okay, there's a non-zero number, a decimal point, and then more numbers. Okay, that's how you should always write things in scientific notation if you're doing it correctly. There should always be a non-zero number first, then a decimal point. Okay, there's always one number, then a decimal point. Okay, if we take a look at just using scientific notation, okay, so here's a number in scientific notation, 3 times 10 to the 8th, and we're supposed to put it in standard form. Well, there's no sign on it, so we know that the exponent is positive. It's 8, so it says move this decimal point 3 places or 8 places right. You notice you don't see a decimal point. Okay, when there is no decimal point, remember it's after it. 3 and 3 point are the same thing. So I need to move that decimal point to the right 8 spaces. Okay, so I'm going to have 3 and then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 300 million. Okay, so that's one way we can do it. Now, what if there are other things going on in here? What if it's negative? Well, this has got 1.64 times 10 to the negative 4th. Okay, so that means move my decimal point 4 places to the left. Okay, 1 place gets me right in front of the 1, and then I need 3 more places in front of it, so I need some more zeros. So I have 0.000164. Now always check yourself. Okay, if I move this 4 places right, 1, 2, 3, 4, I get back to where I was, and okay, so I did it right. Okay. Now, what if we want to go the other way? What if we have a number in standard form and we want to put it in scientific notation? Well, remember, this almost looks like scientific notation, but then we realize it's just a number. Okay, my decimal point it started here, but I need it to be over here. Okay, so I'm going to move it 2 places left, 3.1278. Okay, but these two things are not equal, and I can't change the value of them. Okay, so I have to remember to put my multiplier on it. I moved my decimal point 2 places left. To get it back to where it was, I need to go 2 places right. So I know this is going to be times 10 to the second. And if I actually carry out that operation, I can see I'd move my decimal point 2 places right, and it'd end up back to where it was, which is good. We don't want the value to change. We want the value to remain the same. Okay, so I moved it 2 places left. To undo that, I have to move my decimal point back 2 places right. Okay, if we have a number that's smaller than 1, okay, so I have 0.00574, then I'm going to move my decimal point after the first non-zero digit. So I want 5.74 but since I moved that decimal point 1, 2, 3 places to the right, I need to move it back 3 places left in order to get back to where I was, right? I'm not changing the value of this number, just the way it's expressed. 5.74 times 10 to the negative third. And let's take a look at one more, a really big number, 700120000. Okay, a whole bunch of stuff. Okay. Now, you'll notice it's tempting to go 7. Oh, there's zeros, I don't have to care, and then go times 10, but there are some non-zero values in here, and we need to include all of those. So we don't want to do it that way. We're going to actually go 7.0012 times 10, and now I've got to figure out how many places am I moving my decimal. Okay, it started right here, and I'm going to move it to right here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so times 10 to the 11th. I moved my decimal point 11 places to the left. To get it back where it was, it's got to go 11 places to the right, or positive 11. Okay. Now, the last thing to take a look at is what do we do if we have to do some math when scientific notation is involved. Okay, and usually I'm all for doing math in your head and making sure that things make sense. Sometimes with scientific notation, there's lots of zeros, and it gets to be kind of a hassle. And your calculator is smart enough to do scientific notation for you. Now I want to show you something. Okay, your calculator understands scientific notation and has a built-in shortcut key for it. Okay, so if I have my calculator here, and I have 1.36 times 10 to the third kilograms times 4.52 times 10 to the fourth, I can put it in like this. Most scientific and graphing calculators have an EE button. And this one is actually a second function. It's above the comma key. Okay, and so above the comma there's 2 E's. And so if I put in 1.36, the times 10 to the is replaced with that EE. So second EE, and it puts that E in my display. And now I just have to put in my exponent, 3. Okay, and my calculator understands that that's 1.36 times 10 to the third. Now I'm supposed to multiply that by 4.52 times 10 to the fourth. Okay, so again, e to the fourth. You'll notice I'm not using any parentheses. My calculator gets the way this works. I push enter, okay, and it tells me the value 614720000. Okay, so I can go ahead and write that down here. I have, let's see, 6147200. But remember, these were measurements. These had units. These were telling me something. Okay, so since I took kilograms times meter per second, my unit turns out to be kilograms times meters per second. Okay, it's momentum. And I don't have to put this in scientific notation. My calculator didn't, although if you were instructed to convert this number to scientific notation, we'd want to put our decimal point right after the first number, so 6.1472 times 10, and how many places did we move? 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th kilogram meters per second. Okay, let's do another one with division. Multiplication, subtraction, addition, it doesn't really matter. Just make sure you're paying attention to what you're doing. Okay, and I wanted to do division because, well, sometimes we mess up our signs on division. Sometimes we mess up our units on division. Now this does say 3 times 10 to the 8th, so I'm going to go 3 second e to the 8th divided by, okay, 750 times 10 to the negative 9th, so e negative 9. Okay. Now I'm taking a big number, 300 million, divided by a little number, 750 nanometers. Okay, enter, and that actually gives me a really big number, which is what I expect. Okay, 4 times 10 to the 14th. Okay, that's how you read that. You do not read that as 4e to the 14th. Your calculator is telling you scientific notation. Okay, so I don't want you to write over here for an answer. I don't want to see 4e to the 14th. That's what calculators say. It's not what people say. You need to think about it. Okay, 4 times 10 to the 14th. But now we have to deal with our units. Okay, I took meters per second divided by meters. Okay, so meters per second divided by meters, and that's really meters over 1. So this becomes meters per second times 1 over meters. That meter cancels that meter. I'm left with 1 over seconds, or per seconds. So 4 times 10 to the 14th per seconds. Whoops. And